So it is recording now. And I still see the bouncing lights there, and I see the bouncing lights on the microphone.
Hitting record was your first mistake.
Probably. All right, let's talk about subqueries. So, anyway, I had thoughts on this one because I think it's a great topic. But I can't even type database right. My feedback is going to be really bad this year, everybody, and I'm okay with that. So there is a sample database you can get online. It's called Paella. I don't know how you pronounce it. Doesn't matter. It's on GitHub. You can follow this link. If you've got the slides up, you can follow this link to get it. You'll end up downloading it, I think, as a zip file, if I remember correctly. Or no, it's a SQL file. Here we go. So if you look on GitHub, here's a couple of scripts. I'll go over which one is the one I use for the example tonight. But there are three different things. So if I use this, I think it's the Paella data.sql. If you look in this file, it has a whole bunch of data that it puts in. Like this, the file itself is a very, very large file. It sets up data structures. It inserts data. It's meant to like teach people or show a real world use of Postgres. So yeah, you can see it's a pretty darn big file. In the vein of continuing to use Docker, I'm going to use a tool that comes with Docker called Docker Compose. And the reason I'm doing this is I can tell my Docker container to run a SQL file when I start it, which is kind of cool. So the file is quite simple. It looks something like this. It says what version of Docker Compose it's going to use, what services or containers I'm going to start. It's going to name one of them PG for Postgres. Going to use this image. You know, like when we started all our Docker containers from the command line, the last thing on it was Docker. That was the image. So here we'll use a Docker image, open the ports, and here's the magic for what I'm trying to show. It's going to take the files from a PG folder and move them into the container in this path, docker entry point nedb.d. So it'll take a .sql file and put it into that folder on the Docker container. So when the Docker engine starts, it'll load, it'll execute all those SQL scripts in that path. So you start it by using the Docker Compose up command, and you'll see the output saying it's starting my file, etc., etc. And the fun part that I'm looking for, I don't have it captured in here. Actually, let me do that right now. Let me run it. Whoops. So you see I should have my Docker Compose file here. Make that a little bigger. And I have a PG folder with a Paella insert data.sql file. So when I run Docker Compose up, it will start my Docker container. And it did a whole bunch of SQL stuff. But it didn't work. Why did it not work? Let me make sure it's not already running. Oh, it was already running. Right. If this doesn't work, I'm going to be really embarrassed. Let's get rid of whatever this line of code is. Let's stop that. It doesn't like whatever that is. It worked before, I promise. I wonder if there's a new version of Docker in the dockyard that didn't like that statement. But you can see it's running now. It's doing a whole bunch of insert statements. And that'll run for a while. And my computer fan is starting to run up. So now I have a Docker container running with Postgres like we've been doing all semester with data in it. So if you wanted to learn more about Docker Compose, you could. It's a way of having one configuration file that can run multiple Docker containers at the same time. You can build interactions between them, dependency chains, all that kind of cool stuff. So let's look at the data. So the Pagilla project is a clone of the Sakila project from MySQL. What it's intended to do is represent a DVD rental store to give you context of how old this database is. And it uses film and actor names from a Dell sample database. So if I go to Sakila information, this is just how they do it in MySQL. But the concepts are the same. That's just ported to Postgres. So looking at this ER diagram, we can see our schema. So here we can have a city, which is in a country, address, store, customers, inventory, rental, staff, payment, all kinds of things you would think of for a DVD rental store. Are y'all old enough to have ever rented a movie at Blockbuster? Probably. I think you are. Okay, that's what I thought. Maybe when you were kids, but that's okay.
VHS.
Oh, yeah, okay, good. Well, I know Greg. Yeah, anyway. All right, so we have actors, films, languages, film category, and categories. That's the data that we're going to be playing with tonight because I want to show you some fun SQL. All right, where was I? I'm using a similar data set in my next class, but for different reasons, so I may speak wrong, but I'll try to correct myself. So a way, I didn't know much about this data when I started. So I was trying to explore the data, and I'm going to show you a way of exploring data. And I will get to subqueries. I promise. We will get there. So if I'm in Postgres and I want to do my, oh crap, why do I always forget where this is? Oh, they moved it, that's why. Tools, query tool. All right, so if I'm in here, I can start executing some SQL. So the first thing I wanted to do was just kind of find out what tables do I have. So I can select table name, table type from information schema. So information schema is a schema of its own. If I can type dot tables, which is a table, where table schema equals public, because all the stuff I did was in the public schema, and table type equals base table. So when I run that, oops, I'm trying to find my shrinkies. I guess I can't really shrink it well. Nope, don't do that. Oh no, don't do that at all. I'll leave it there for now. You can see there's a bunch of tables: film, actor, address, city, actor, category, country, etc. that was in that ER diagram. We can talk about later why there's multiple payment tables, but that's a more advanced topic. How do I dock that again? Does anybody know how I dock that again?
Maybe you have to stick it down.
That's what I was trying, but it doesn't really. Oh, maybe that did it. No, that's the row. If I double click it, no.
You have to drag it and drop it next to the query history.
Query history. Yeah, it doesn't seem to be doing anything. Bonus points.
I Googled. I can't remember. It's like you have to completely shut down, like reset, like the default view. Like it's not something you can just easily do.
That's
I
what
can't remember what it was.
That's what I was afraid of.
It is painful.
That's what I was afraid of. Alright, let's try that again. Okay, it looks like... No, it's still floating! That's alright. We'll deal with it floating. Alright, so I get those tables. So this information schema is a way you can describe your database if you are so interested. This is my discovery of what data I got. So one of those tables was actor. Let's find actor. So, oh, why isn't it? There it is. Row 4 in my result set of the schema. So let's look at what the data looks like. Select star from actor where, oh, I did a limit 10. And now I got, oh, see, I want you to go away. See, that one let me collapse it. Anyway.
Can you hit, is there a thing for file?
No. Properties.
And then reset layout? I just did a Google.
Let's see if I get back to that.
Oh, there's file.
Where? Oh, file, reset layout. Okay. Reload. Let's see, that might have helped. Thank you, thank you. I think that might have helped. Well, let's see when we get here. Query tool. Hey, bonus points, thank you.
Yeah.
All right, where was I? Select star from actor, limit 10. So, and that moved up there. I don't want that up there. I want that down here. You can see the data that's in here. I have a primary key actor ID. I have a first name, a last name, and a last update time. Cool. Then we have films. Select star from film, limit 10. So I see a whole bunch of stuff. Academy Dinosaur, Ace Goldfinger. I think these are all fake, but that's okay. Alabama Devil. So I get a whole bunch of films in here. Now let's look at this. Star from film actor. Anybody want to make a guess what this table is? Based on its name?
In each film, not actors.
Okay.
It's also joining the actor table and the film table because they both have it's a many-to-many relationship.
That's what I was going for. So if we looked over at the ER diagram, let's see if I can find film, okay, actor, film with film actor in the middle. We have the many crow's feet here, the many crow's feet here. So between these two tables, we have a many-to-many relationship. And so when I query that little table, I get a primary key for the actor, a primary key for the film, and that is it. So how would I build a list of actors in a film? Anybody want to help me with some query? A list of actors in a film. Let's say film, I like that, Alabama Devil. How do I find all the actors, actor first and last names from the film Alabama Devil?
Select first name, last name from actor where, from film actor, where film name equal to Alabama.
Nah, it's not gonna work.
I know.
Film ID.
I know it's not going to work. Hold on. I want to show you why it won't work though first. So the film actor table doesn't have a first name and a last name, but we're on the, this is how we start. So
You have to use
You want to join to the.
I need to join. What am I going to join from? Like, remember left and right joins, right? Left being, this will be an inner join, but if we were thinking left and right, what would my left table be? What am I rooting my query on? The actors or the film?
The film.
Film.
I think the film, because the question I asked, who are the actors in the film Alabama Devil? So if we think about like what table will I be filtering to find something? It's going to be the film table because I want to start with the title of the film. So if we started like that, if I select star from film, where title equals Alabama Devil, where title equals single quotes. I was just writing Python. I have information about my Alabama Devil film. So that's good. So how do I get to my actors now? What do I have to join to first?
Common.
Film actor. Film actor on ID.
How do I do that?
Yeah.
Syntax. Give me syntax. Starts with
Left join or inner join, don't matter. Inner join. Inner join, so you have to put the name first.
Table name and then dot.
In between join and on.
yes.
Inner join film actor on filmactor.id equals film.id. It looks like it's film underscore ID is the name, not just .id.
Yeah. Film underscore ID. Okay. Select star from film, inner join. Okay, so this should now give me a list of the films and the IDs. And the many-to-many join table. Oops, what did I do wrong? From film.
Underscore.
Yeah.
Film actors.
Film dot film underscore ID, I think.
Film ID. Okay, sorry. It took me a second. I'm slow today.
Can you read the descriptions real quick?
Oh, of the movies? No, that may not be appropriate.
Okay.
Okay, so now we have successfully joined the many-to-many table, the inner join table, and I know that because I got more than one record back. So I'm going to tell you there are more than one actors in this movie. One or more actors in this movie. Yeah, more than one actors in this movie. So what do I have to do now for my join? I have to join to another table, right?
Inner join to actor.
Actor ID.
Is there actor ID? Maybe a select star.
So far, so good. Well, I want to change my star to first name, last name, because I think that was my original question. And so now we know Christian Gable, Elvis Marks, Rip Crawford, etc. are in that movie. Pretty cool.
A question, Chris.
Yes.
Is there a shortcut that we can replace the Drew inner joins? It's just kind of like when you put in the Drew inner joins, it kind of slowed down the performance actually. So is there another shortcut to join the table without using two tones?
No, there's not, because we have to make two different joins. But I like your question about performance. Looking at this query, what's the slow part of the query? Assuming there are indexes on all the primary keys. Are we talked? No.
It's movie title,
Why would movie title?
because it actually has to go through each. It actually has to go through each title field and see if it equals out to Alabama Devil.
Yep.
So you go one at a time.
Yep. And so what was do you remember the tool we used to, or the query command or whatever you want to call it, that we used to figure out how efficient a query was? We did talk about this, I think. Maybe like a year ago. I don't remember. Come on, Jess, you should know this one. It starts with a P.
Partition?
Wrong P.
What is it to clean up the?
To see how
make it
see how efficient our query is, or not efficient. How? Nobody? Oh, don't make me find previous slides. Shoot, I couldn't even tell you when the heck we talked about that.
Is this after the midterm we learned it? Because everything since then is fucking correct.
Maybe.
Performance?
What's that?
Performance?
That I'm
That's
looking.
too easy.
I'm looking for a term to help me find.
Curiosity?
Nice try. No, now I gotta find when the heck we talked about it. That's Redis. We didn't talk about it in Redis. Well, that's JSON. We didn't talk about it there. See, now I've got to find it. I swear we talked about it. Did we talk about it recently? No, that was Elasticsearch. No. Okay, the answer's plan, I think. Query plan. But see, now I'm going to forget the actual word. I am. Postgres query plan. Explain. Okay, I totally threw you off. But it is a query plan. But we talked about explain. My bad.
Yeah, I remember little bit.
Yeah, I barely remember it, so it's okay that y'all don't.
I was
So what this tells me is when I read through this, I am running a nested loop. I'm running a nested loop over for whatever. It tells us a cost. Oh, so this is doing an index scan using the index on title to find Alabama Devil. That's good. I didn't actually think there would be an index on here, so I thought we would see a full table scan. So this one's not actually inefficient at all. So we use a index on the title to find the film with the title first. Then it uses another scan on an index for the film ID, and another scan using a primary key for the actor ID. So this is as efficient as you can make this query.
Another question, Chris, is also relevant to this one. Because what is the underlying assumption that make you think there weren't an index earlier, but now it turns out that we have index?
I just I have no reason to have assumed or not assumed, and I just assumed there was not a plan or an index, but I could have checked. So if I go over to my schema browser here, I can look at my table film, expand that, look at my indexes, and I can see, ooh, I even have a full text index on something. I don't know on what. I wonder if there's a way I can figure out on what. Restore maintenance properties. So there is a full index on the full text column. So there's apparently a full text column. I don't know what's in it, but there's a we talked about Elasticsearch being a full text search engine. There is a full text index on that field. That's kind of cool. There's a foreign key on language, foreign key, and an index on the title field. So had there not been one, I was going to create one and show you how awesome I was with databases to make this query faster, but it was already there.
So how could we know if a query gonna create an index or not?
So can I rephrase the question? How would we know if
Sure.
a query uses an index or not?
Because I think because you run the query, that's why the index was created. In the beginning, it wasn't there. Is that correct?
No, the index was there.
Okay.
Chris
How was
Chris
it-
just didn't know it was there.
Oh, okay. And why was it there in the beginning? Like we had to create that in the
Yep.
beginning? Or it just-
Because whoever created this database knew that whoever was querying the database would be querying by the title, because we would query things by a movie title and not by a movie ID field, because a movie ID field has no context outside of the database. But Jurassic Park is always Jurassic Park, right?
Okay.
Alabama Devil is apparently always Alabama Devil,
Yeah.
whatever
so this,
that is.
Yeah, go ahead.
No, I was just making more snarky comments.
So this time it comes to the domain expert. Like, if you are a database administrator, and when you create that, you kind of guess how people are going to query their database. So they create the indexes in the beginning, like beforehand, just to make our work a little bit easier. Right?
Yeah, so you either guess or from the analysis of the business, because you did your interviews and you talked to the people who will use your database, you know what they do. You know, if we were making a movie rental business, or if we were making Netflix, right? What's the first thing you do? You search. I usually search by either a genre or a movie title, maybe an actor, right? And so you, as the person creating the database, you would know that a user is probably going to search by title, genre, actor. So that's where you put your database indexes, because you need those queries to be really fast.
Makes sense. Good to know. Thank you,
Yep.
Chris.
All right, so we have pulled actors from our films, yeah, and got their names. Promise I'm still getting to subqueries really soon. Go away. There's another interesting metric in here. Select star from sales by film category. Sports 5314, sci-fi 47, etc. So these categories of movies, the genre, we can calculate the total sales. But going back to our, oh crap, where did that picture go? Now I need that picture again. Our table structure, you will find that there is no sales by film category, or sales by film category table. I see a film category. I see a category. So this is again a many-to-many relationship between film and category, right? Is it too small? Film is here in the middle. Film category at the bottom, many-to-many relationship, because something can be a comedy horror movie or a rom-com. There you go, romantic movie, it's comedy, right? So it could have multiple categories, so that's kind of cool. But the only relationship to the film table is to the inventory film, or the inventory table, which is then related to a rental, which is then related to a payment. So I didn't do 12 inner joins on this query to figure out my sales by category. How do you think they figured out sales by category? Using things we have learned.
A view?
Ding, 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 a view. So if I go to my views, let's see what we have. We have a whole bunch of views. Actor info, customer list, film list, nicer but slow film list, sales by film category, sales by store. So yes, the sales by film category view is probably a big SQL query that joined all those things. Oh, I can't go that far over. So maybe let go. There you go. So select name as category, the sum of the amount from join, group by, order by. So I didn't have to run this query because it was in a view. That's one of the reasons we use views. It was to simplify the interface for our database users. But when I run that query as is, I get the exact same results as we would expect. So if you are going into a business with an existing database, This tool, something like pgadmin or Toad or SQL Developer, whatever, they will give you things like this interface to help you discover what data you have. And even if they don't, you can go back to that original query, starting at that information schema table that's in Postgres, to see what all's out there. So now I have a question. Comedy is my favorite category. I'm not sure that's true, but for this example, comedy is my favorite category. What categories outperform comedy? How did I figure that out?
Can we make a subquery to calculate the performance of comedy first, like irrigation, and
Okay.
then we only select the result that is higher or greater than the one that we just calculated.
Okay, so we'll select from sales by film category, where category equals comedy. Let me just make that a little easier to read. Can you all read this on the right? Is that big enough?
Yes.
Maybe, yes. Cool, thank you. I'll run that, and I get my comedy. So I know my comedy is 4383.58. All right, now walk me through the next step. How do I do this?
Can you set that value? Anything greater than the value?
Okay, how would I do that? Guessing.
Well, if you
Yeah.
know it's changing, is that going to screw it up?
Say again?
If it's constantly changing, is that going to...
Can we just select as normal and then we put the whole thing that we just done to the where clause?
You could do select star from sales film category where, and then parentheses, or no, excuse me, where
Yeah, parentheses.
sales is greater than parentheses, select total sales where category equals comedy. And that should give you what you need, right?
Yeah, I'm thinking the same. Thanks.
Yep.
Query.
Hey, we're at a subquery.
Yeah.
So this won't work.
No, that won't work because you're selecting star.
I know. So this is saying, but I did that on purpose to show you why this won't work.
You just don't know what you're doing.
Look, if I go to my next slide, you can see I have it right here.
It's just all copied.
It's right there. Okay. Select star from sales by film. Oops, I can't type. Film category, so ignore that error. That was because I typed it wrong. Here's the error. Subquery must return only one column. Makes sense because I need to compare my total sales column, the value in that field, to a single number. So what would I change this to?
Total sales.
If that was the name of the field, which I think it was. So my subquery is select total sales from sales by film category where category equals comedy. I know I'm going to get one result, and that's a good thing. And select star from sales by film category where sales is greater than, I'm going to throw in an equals because I want to, the single value I get from this table. And now I have successfully built a subquery to kind of ground the number. Like I don't know, I can't type the number ahead of time because I don't know what the current sales by category is. So I have to query the database to get that that value to then use in an outer SQL statement.
I have a question, Chris.
Yes, ma'am.
Just imagine that we don't have the data of total sales. That it means we have to calculate the total sales. How can we nest the query that we use to calculate the total sales before, like we can do step by step, but if it were a case, is there a way that we can nest the calculation into that query?
Absolutely. So sales by film category in this example, I'll just be using this table, is a view, right? that view, because it's not a materialized view, it's just a regular view, is really just this query. So I could do this in 2 steps. I'm going to replace my inner query, my subquery, with that query. And I know, but I only want comedy. Having C name equals comedy. Having. No, having is not. Yeah, that might work. No, maybe not. Select star.
I thought having was just for like the aggregate.
That's what I'm trying to think. Is it? You're right. It is. I'm trying to think. Is it after the
It would just be
grouping?
where.
It would just be where. Yep. Where C name equals query. All right. And then run. And I'm going to have that same multiple. Oops, I have a semicolon there. I got to get rid of. And I know it's going to have multiple returns, but I really just want the amount returned. That's what I was looking for earlier. Okay. So I run this, and I should get that same result. Sports, sci-fi, comedies down here at the bottom. I can't see it right now, but it's down there. There we go. 3383, and I get the results. Now I'm still using my view, which I don't necessarily want to, so I can start tearing this apart and changing my view to use, or my outer query to be the same thing. But I wanted c.name as well here. I'll explain this once I run it to make sure it works. Where total sales. Oh, here we go. Sum of having. This would be a having. No, it wouldn't be. Oh, see, now this is getting trickier. Yes, this would be a having.
Yep.
So now I've confused myself. So this where clause goes away. But I still want the subquery. Group by CNAME. Having total sales greater than or equal to that. Maybe? Maybe? Okay, see, that's because of this. Group by, where'd it go? Having some, maybe?
Not the alias.
See, this is why we use views. Because otherwise, there we go. This is a ridiculous query.
Yeah.
Go away. Go that way. Okay. So let's go through it. So you can see I don't even want to explain this. My inner query is essentially the same. I am selecting the sum of the amount, all the joins, where name is c.name is comedy. So I actually really I don't need that order and group by, or that order by, because we know I'm only going to get one result. But this returns the same value of the comedy total sales. And then my outer query, select name sum, the sum of p.amount as total sales from big join, grouping by CNAME. And since now I have to do the comparison of the aggregate function, I have to use having instead of where. So having the aggregate function value greater than or equal to the subquery. So if you ever find yourself writing a query that looks this ugly, views might be a good help. Because then I am just, here it is. No,
So
that's...
the inner query executes first and then the external query?
That's exactly right. Yep, I must have deleted it. But yes, that's exactly right. So let me go back to what it was, what I liked it looking like. Select star from sales by film category where total sales is greater than or equal to, select total sales from sales by film category where name equals comedy. Oops. Is it not name? Oh, category, not name. Category. I like that one better compared to this one.
A quick question, please. Next to view, do we have any other alternative to streamline our query? On the top of your mind.
I mean, that's when you can start getting into store procedures, and you could have your store procedures do a lot of work, but your query looks like you're just selecting from your store procedure.
Okay. So view must be the most commonly used, right?
Oh yeah, most certainly. Because you write the query once, and you make it look like something a lot simpler to deal with.
Yeah, I'm just thinking next to view, do we have any other alternative options, or
Let's go through here. Let's see. We have views, types, triggers, tables, sequences, procedures. So yes, functions. I think functions is the right word, not procedure. But yeah, functions, tables, domain. Yeah, so functions would probably be your best bet. Let's look at that. I'm curious what this function looks like. This function is a simple query. Select inventory ID from inventory where film ID equals parameter 1, parameter 2. And then I think it's using another view. But yeah, so this function has a return type of integer in this case. But there you can have a return type of a database table row or a cursor, so you can get multiple rows back. But this one has a predefined two inputs, a film ID and a store ID, and then a defined output of an integer. We haven't really talked much about functions in detail, because in a lot of ways they've kind of gone out of style for a lot of folks. But this is a good reason to make determining if a film not in stock. You put the code in the database, so the database knows how to determine if a film is in stock or not. And the application that's using it just has to know the function name, not all the details of the database. So you're abstracting away the structure of your database, and that's always a good thing. All right, so where was I? So let's make this bigger. Yeah, so we ended up with this same query to get the answers. So we touched on one of these concerns, or the syntax. So the first one, I have select star from where total selects in the subquery had the multiple columns being returned, and we got the error saying subquery must return only one column. The second one, select star from sales by film category where total sales is greater than. Notice I'm selecting category and not total sales. I get a no operator matches the given name and argument types. It can't do a comparison between an integer and a string. So that's another kind of common error you might see. And that's what I have for the slides. I know that was a very short overview of subqueries, but that seemed to be kind of a nice, easy way of showing it. The subquery can be all kinds of different things. It can return, it can be used in this manner. I think you can use it for comparing more than one value, but I'm not sure how. We'd have to figure that one out. Like, if I wanted to if I wanted to compare the total sales and the category. I think I can do something like this. This is a weird example. What did I do wrong? Oh, I forgot that one. There we go. So here, my subquery is returning two values, a category name and a total sales. Bad example, but I'm comparing it in my where clause to those two columns at the same time. That way I only have to execute the subquery once. And if you were doing something like this, your subquery would probably be more, in this case I'm only getting one result in the end, so it's kind of redundant. But if I were querying a different kind of table, like a user preferences, and I wanted to get the genre and the list of tags that users put on it, I could then compare a genre and a tag to find what users would match that movie, as an example. Let's see if I have any tables like that. Films, actor.
Professor, so when exactly we need to use a subquery, or is it like only on practice we'll come to know when to use and all those things?
Yeah, so the way I think about things like this is we really only write queries based on data that people need, whether it's for a report or for an application or something like that. So looking at this database table, I could envision this kind of question being asked where somebody's analyzing how much space to put on their shelves. So what categories have high sales based on the average sales or something like that. And so that's another bad example because I could do that without a subquery. But this question, a question like this can't be answered without a subquery or without multiple queries. I can't join to anything to answer this question. I can't, and that's really what it is. I can't join to something to find the answer. So finding something like the total sales of a specific category, I can't do an inner join to anything to figure that out.
Oh, okay.
Now, I would, for this one, maybe we could do something with the window functions that we talked about. But this is the most straightforward way of answering that question. I'm really bad at coming up with examples, so I can't come up with other examples.
Yes.
Mm-hmm.
I have, because I think just in passing you mentioned the schema earlier. I'm not sure if anyone in here experienced the one of the error from SQL saying something like, when I tried to create a function across schema, it said it showed me an error message saying cross table problem with schema. Just kind of like the way SQL reads it, like database dot schema dot table.
Yeah.
But when I tried, what I was trying to do is try to enter the schema dot table dot column. So it showed me an error message. And when I looked up online, it just kind of like something is vanished from Postgres, and they don't know how to solve it.
Public dot actor. That should work. Here I'm specifying what schema the table is in. In this case, I only have one schema, so I can't really join it to another schema. Is that what that kind of syntax that we were talking about?
Unfortunately, I forgot to document the process, but I came across multiple times with the same error about working across schemas.
Okay.
It's in my project anyway, and in the intention to simplify the submission, I just leave it out. But basically, in real world, we have a lot of schemas to work on, and I'm not sure what we to do with the error like this.
Yeah, so that it sounds to me like that's a permissions problem. So if I created another schema, create schema Chris. I think I can do that. Okay, cool. So now let me go refresh my schemas. So now I have 2 schemas. And I don't have any tables in my Chris schema, so let's say create table. Well, how do I do it? I think I have to use a database.
Are you trying to give create user first and then you grant the users on schema?
Right, but I already have the user. The user has permissions on the schema. Postgres, which schema? It's like a default. How to select a schema? Postgres. Show set. No, that's a search path. I don't want that. So the syntax is the schema name dot the object name, like the table. So you can, if you have multiple schemas with related data, this is why you would have multiple schemas. So given whatever domain you're working in, schemas can be used for privileges or data storage. So they're stored on different disks or different servers even. You can have a sales user has access to your sales schema. Now your sales schema can reference your inventory or your product schema, but you don't want your end user to modify your product schema. You want them to be able to modify the sales schema. But you have an administrator or a reporter who should have access to all of the schemas. And so you can join tables across schemas.
That sounds more complicated than expected.
Super complicated. No, I mean, it's not. With practice, with time, I mean, I think it'll come just as a different way to organize things. And like I said from the beginning, my goal isn't really to make y'all database administrators. It's really to show you the structure of data, how to use data, what do queries look like. You know, things that I imagine that you would be doing in the jobs that I hope you have soon. And I don't think any of you want to be a database administrator.
That's just popped up out of my curiosity because I should have documented it, but I forgot. But I think it's really practical.
Yeah. Well, when you said you had that error in your project, though, that kind of concerns me.
Yeah. So I had to dock all the tables and like create everything afresh.
Yeah. Yeah. I'm wondering if somehow you ended up with like using Docker or something. You ended up with multiple schemas accidentally, and some of your queries were in one and your data was in the other. I don't know, something like that.
Yeah, I will try to do a mock-up again, and probably I will make some documentation and provide it to you by email.
Yeah, if you figure it out, let me know, please, because I would love to look at it and try to help figure it out.
Sure.
Now I want to find out this syntax. Create table. Okay, so I specify like that. Create table Chris dot accounts int whatever. Nope, no, not as. I always throw in as's. Okay, so there. So I can now. But since I have permissions, I can select star from accounts. Select star from accounts. I said it, I didn't write it. Okay, so now this is where it comes to that search. Where the first thing I pulled up in here. What was the question? Postgres. Search path. That's what it was. So my search path might just be my public schema. Yep. Oh, and so now I can change that. Search path to Chris and public. Now I should be able to run account, select star from accounts because it found it. Now this is the fun one too. Public.accounts. Okay, so I inserted a value into each of my accounts tables. Anyone want to guess what happens when I select star from accounts?
Gonna break.
That's one good guess. Any other guesses?
I'm gonna ask you which schema.
Might ask me which schema.
Or it'll show both, maybe.
Okay. I have a feeling it's going to show me the one in Chris first, because that's what my search path is. It'll look for the table named accounts. It'll say, ooh, here it is. Here's the data. That's my guess, but any of them could be right. And so if it's coming from Chris, the value should be 1. If it's coming from public, it should be 2. So there, pulled it from 1. So it pulled it from Chris, but now if I change the search path, the other way, I should get the other value. I should get 2. Okay, so it does go in order. It searches for that object. Ooh, so now, going back to our data hiding model of salespeople versus admins, you could have the same table in the two schemas, and you could hide data in the admin or in the salespeople table. You could put dummy data in there, remove people's salaries, but your administrator could query the real salaries. Oh, that'd be fun. That'd be a great use case, or a great way of using a search path. I like exploring technology. That was kind of fun.
Chris?
Yep.
Another thing. I'm sorry if the other people have any questions, because I think I'm a little too detailed on schema, and I don't want to hold people back.
Well, yeah, we'll get back to you, Melody, but anybody else have a question, or are we going to go to Melody again?
Okay, thanks. So normally I see you use create or replace the table just in case you have something existing.
Mm-hmm.
But when it comes to schema, let's say create or replace schema dot table name. It did not allow me to do that.
So,
do you want to try that out?
Yeah, create or replace table chris.accounts ID int first name. Let's change it just to change it. Can you create or replace a table? I know we can create or replace functions.
Let's try function, Chris, because the cross database error that I got, that it happened when I was trying to create a function.
Okay.
Did you need to set your path again, maybe?
So there is no create or replace table construct at all. I just checked the docs.
So probably I forgot that one.
Yeah, I'm just doing a quick.
I might have misunderstood something.
There we go. There, that looks like a great function. Create or replace dupe int1 f2 whatever, add language cast one. Oh good, so I don't have to actually do any tables. Okay, so I created that function, create or replace that function. I can do that. Now if I specify a schema, let me do it.
The schema, hold on. So the Chris is the name of the schema, and the dup is the name of the table.
The name of the function.
Oh, the name of the function.
Yep.
How, and next to it, you're going to specify the column, right? or we don't have to specify the column in a.
Well, yeah, this is a function, not a table. So here, we were talking about earlier functions that have input and output parameters. This function has an input integer as a parameter and 2 output fields. But that's just this function itself.
Okay. Thank you. I'm gonna look into it again.
Yeah,
too.
figure out what you know.
Anything, because when I looked up on the Stack Overflow, there were a lot of people having the same problem with the same message, the cross table schema error message, and they have tons of ways to go around with it, but it's really complicated.
Cross database references, it like this?
Yeah, I think so.
You cannot join tables from different databases. Okay, so when I use the Docker container as I did, the database gets created as Postgres. So let me go back to that Docker compose file. Image is Postgres. So the default database name is Postgres. I can change that to be a different database name. So I could create yeah, I'm not gonna do it, but I could create another. Remember, the database is a structure inside the database engine. So here, my database engine is running at localhost. That's when I run Docker run, right? There is a database construct in it, and within the database, Postgres, this is where I have schemas, language, all this other stuff. I can create multiple databases. I wonder if this will let me do it. Create database, second database. So I've created another database within the database engine.
Are you able to see my text, Chris?
Yeah, create function, format phone number, at phone, varchar 10.
Yeah, I was trying to create a function to change the format of a column inside a table belonging to one schema. So this is the case where you have to specify the column because you want to change like either.
Are you doing that as part of a trigger?
Yeah, but trigger is the later part of it. It stopped me right there when I put in the phone number.
Yeah, I have a feeling it's because, yeah, if you couldn't, why don't you send me your big SQL script with the thing that breaks in it, and that way I can look at it.
Definitely.
All right?
Yes.
Awesome. Any other questions for the night?
Hey Chris,
Yes, sir.
the main purpose of schema to organize your tables or limit access?
Both.
Okay,
Yeah.
thanks.
If I were to, like, in my experience, the primary use would be access limitations to keep one person out of some data.
Okay.
I mean, you can do access level at tables, but schemas can. There's all kinds of properties about schemas, and I think it has to do with storage, like where on a disk it's stored. So if you think about a server with multiple network drives or something attached to it, or multiple physical drives, you can put the different schemas on different drives. So that's more the administrative side of things. So I'm trying to see if I could find anything real quick. Manuals. No, documentation. I'd have to try to find something, but I know there's different ways of updating it, or of organizing data, setting the privileges on the schema, and then like where the data is stored. So if we had like a schema with old data that we would only query every now and then, we could put that old data on a network drive where it was slower to get access to it. But we would put our new data in a schema that was stored locally.
Okay, thanks.
All right, folks. Well, everybody have a good night.